Can you hear me well? At least you can see it now, right? When we start looking at the this thing. So anyway, I don't know whether you have seen the what is that, the Polar Express, right? So in that the Tom Hanks says, if you are looking for penguins, they are on the other end, right? Because the penguins are on the South Pole and he's on the North Pole. So like that, if you are looking for recommendations, they are on the other end and we are here. So this is Pandas, data wrangling and data science in that order. Pandas is the main focus with data wrangling. Not going too deep into data science because we could do a whole machine learning tutorial for a whole day or that kind of stuff, right? The agenda, we will talk about the data wrangling pipeline just to get a feel for what does it mean, data wrangling, with respect to a machine learning ecosystem, with respect to a data science type of work, right? And then we will go into the basic maneuvers. Is everybody familiar with Pandas here? Or there are people who haven't used Pandas before? A few folks are there, right? Okay, so that is a good one. So that coming in, I didn't know how many people were in back and forth. We will take a quick, the basic maneuvers, right? You do, if you are looking at things, you have to at least look at the basic ones and say what are the primitives that we have. So we will quickly go through the basic maneuvers, and then we will go through multiple data sets. The idea is to look at Pandas, to learn Pandas, to understand the various mechanisms by doing stuff, right? Rather than just looking at abstract and saying these are the APIs. So that's what we will do. We have 90 minutes, we will do, and of course we have the lunch time. I'm just kidding, I'm not going to take the whole lunch time, but we will see how it goes. Couple of things. The goals, right? The goals and non-goals. It's always important to say what we plan to do and we don't plan to do. The goals are to understand data wrangling, Pandas, focus on API usage, give you some focus time to work through the examples. It's 90 minutes, so it's not, we can't do a hands-on tutorial, that kind of stuff. I don't know whether you folks got a chance to download download Pandas and IPython notebook, and also the data and the code is in GitHub, so you can get it from GitHub, and you can do that one if you or after this is over. You can go and download the notebooks, run them through. The data is there so that you can take a look at it and you can understand the mechanisms and mechanics. Less theory and more usage, and straightforward as possible. Right? These programs are simple, straightforward programs. They are not too, that way we go through the Pandas, not the rest of the stuff. And this is the foundation for the next two tutorials, right? Visualization as well as the time series. These are the two things coming up, probably they stack up one after the other. Those are the two ones that one can work on. Not on expert Pandas, of course. We have to get through the first level to get to that second level. Time to do hands-on, only 90 minutes. And there is things like, one of the questions that come up with Python and data science is people look at it and say, okay, how does it compare with R and various other languages, right? So quoting Shakespeare, I come to discuss Pandas, not to praise R or whatever it is. So that one. And interactive and hands-on. Stop me anytime, anything that, if you don't understand something, or if you have some questions, if you have some thoughts, if you have some ideas, stop me and we'll go through that one. I do want to thank the folks standing on the shoulders of giants. I have just a blurb about me, the things that I do. I'll skip through because we have 90 minutes. So the installation, Pandas, best done with Anaconda, and the IPython notebook. These are the two, depending on your operating system. Whether it is Mac or Unix or Windows, you can install Anaconda. It has IPython and various other things, and you can also install the Jupyter notebook. The tutorial materials are here. By the way, if you go to my GitHub, it is there in the name of the, if you look at the description, I do have put there as well. If you go there, you also have a link to the slides, so you don't need to write down the link to the slides. Slides are in SlideShare. But if you can't get to the SlideShare, maybe I will put a PDF in here as well, so that way everything is in there. I haven't done that, but I will do that one. So let us quickly, just to get this up and running, right? You have the, usually, okay, this is a good one to see how this thing works out, because most probably I will put it in this mode rather than the slideshow. It's a lot easier, and you can see it anyway, right? Yep. And it is not much in there. Let me see how much you can see this guy. I do have this thing so that I can actually show more, more this thing. How does it look? Can everybody see this one? I want to see. I'm going to just walk down and see how much, so that way I get a feel for how much you can see, right? Yeah, you do need a bigger this thing, right? Okay. So what I will do, yeah. What I will do is I will show, if I show this guy, does this make it easier to see? Yeah, that's good. So then what I will do is I'll focus on this one. So Jupyter Notebook, right? When you type in that one, what happens is it starts up. If you had installed IPython and everything, it will start up. So I am using the old directory, but you will see this one, pre-flight check. So this is the pre-flight check notebook. You click on the notebook, and there is the pre-flight check. So in order to run something, what you do is you press Shift-Enter, right? You go to this thing. You press Shift-Enter, it comes in. You will see that, when you do this thing, you will see the version numbers, right? So it is just a starting, right? So that it tells you that the IPython is installed and you have all the other things in there. So let us hold it there. So this is how, you start up, use IPython to start the thing in. So let us go back. So quickly go through what does this mean in terms of a pipeline, right? We'll do it only a couple of times because I just have a few slides in the beginning, and then when you talk about a data science pipeline, right, where does Pandas fit in the realm of a data science pipeline? You have the collect, store, and transform, right? This is where data comes in from multiple places. You start collect, and collect also could be distributed collect, various other things like Kafka. There'll be various other infrastructures in place where you collect the data. And of course, store. Again, the store could be HDFS, it could be distributed storage, it could even be things like Cassandra, that kind of stuff. And then you have the transform. So this is where Pandas is, right? You have data coming in from multiple places. You want to take the data, you want to slice it, you want to change things around, you want to do various things. That is where the first thing comes in. The reason, model, and deploy. This is a machine learning part. That is a pure data science where you look at the various parts of the data, you create a model, and as iteratively you create the model, in the end, you deploy the model. Right? So now your program, your machine learning, your model, your AI thing is out there in the world. Right? And then things like visualization, recommend, predict, those more are in the UI side, right? The UI and the interactive, your application might have multiple things. So that is just a general this thing. A lot of the work in Pandas is in the transform and probably on the model, right? Because when you have data, you want to look at the data, you want to look at multiple. We will do some of these things as we move forward. couple of things, right? Don Rumsfeld probably is an armchair data scientist, right? The key is this. When you do machine learning, when you do data, when you do these things, right? What you are getting, be very careful that what you are getting is a slice of the data, a snapshot of the data, right? And then you look at the data, so that is not the whole world. So be careful of that one. And so you might look at the inference. For example, there is one thing that one of the data that we will look at is the people click and buy pattern, right? So in that one, it looks at it and says, we will give you like 33 million clicks, right? Tons of clicks. People click on all kind of items, and there is also buys. And then they look at and say, okay, now predict. Can you predict out of these clicks how many will buy? Right? When you look at it and say there might be, say, like probably there might be, say, 100,000 items, and the buys might be only 20 or 30,000 items, right? So from that one, you can't assume that rest of the 70,000 items nobody is going to buy. Remember, if you look at it and say if the data is from, say, March through September or something, and there might be items like Christmas ornaments, right, which people wouldn't buy unless and until you have the data from December. So the key is to make, so there are things that you know and there are things that you don't know. So always keep that in mind when you look at the data, when especially when you are looking at averages, you are looking at various standard deviations, you are looking at various other things, you group by, etc., but make sure that things that, oh yeah, this is only a slice of the data, there is this huge world out there, and things do change as well. So I just wanted to bring that up. I'll just pass on this one. And let us quickly look at the APIs, right? The Pandas API. So that the idea is, probably you all know Pandas, but still I just want to make sure that we have a, everybody's on the same page type of stuff, right? The Pandas, first of all, the Pandas is a layer over NumPy, a very nice layer. It's probably a slightly thicker layer with a lot of data, this thing, right? Brandon says, right, in Pandas nothing is impossible. It's an interesting this thing, right? You can do that, but you got to figure out how to do it. There are two important data models, right? The series is a column. Series is a column, and it is somewhat like a NumPy array. We will see that how it comes together. And the second, data frame. Of course, data frame is the data scientist, the best tool. And data frame, of course, is a 2D. It is like a spreadsheet. It has columns and it has rows. The key, another interesting thing is, you have operations, like for example, if you look at correlation, if you look at string, split, various other things, right? Usually in Python, these things act on a one variable, right? If you give it a string and then say split, it split the string. But they have extended it so that when you do a split on a data frame or a series, you get another huge column, right? It splits each one of them. When you say correlation, it does the correlation, or when you say covariance, we will see all those things. So when you say, right? So these functions act on a column or on a data frame. We will see how that comes together. Pay attention to the index. The way the Pandas works, right? The Pandas is not an array. So you cannot just say, give me the zeroth this thing. It is labeled rows and labeled columns. Keep that in mind. Again, we will see as we move forward. So that is, let me do one more slide just to say the objects. You have the series objects, you have the data frame, the panel 4D and index. I'm using the index in one or a couple of places. Otherwise, it is this one. IO is read. You can read CSV, you can read tables, you can read GBQ, that is a Google BigQuery, right? GBQ, you can read any of those things. You have the computations. NAN is interesting, missing data. Again, when we come to it, I'll discuss more on the missing data, how that works out. The whole date time functions, lot of date time functions, right? You take the dates apart. All of these things are under the .dt namespace. And then you have the .str string operations and .plot. The reason this namespace is important because when you are looking at something, you'll suddenly look at and say, maybe you will look at and say data frame.split. But it won't work, right? Then you look at and say, what's going on? Then you look at it and say, oh yeah, split is, you have the str namespace. Right? You look at it and say, str, so data frame.str.split, immediately it works. So it's easy to, a namespace and how the APIs are organized, it's important to understand. So that way you know where to find what. This is just a data site. I have it in the slide so that when you can take a look at the slides. When you look at the slides, you will see some interesting things you can think about it, that kind of stuff. So without further ado, let us look at the basic maneuvers. Right? Basic maneuvers. We go back into the first. Let us get rid of this person. We have the basic maneuvers, which is 0, 1, 0. So now, let me see. I'm going to try Command plus, and if that works, it makes it easy for all of us to see. How does it look? Is it good enough? Because if I do a more, okay, I'm going to hold it there. So you might see something cut off from the other sides, but still you can see that one, right? You can see from the back end, you're okay? You're fine, right? Okay, good. So, first one, it's always, just I have a couple of this thing, date, time. Item number 1, right? Data in and out. Data in and out, it reads CSV, it reads delimited text files, all of these things. We have our data in a CSV file. So read.csv data, and we have the car data. This is the car mileage data that we have. Let us look at what exactly is there. You read the data, the basic operations, right? The first thing you want to do, when you get a data set, you want to look at and say, how many rows, right? What is this data all about? You look at it and say, yep, there are 32 records in this one. Miles per gallon, displacement, HP, torque, RA ratio, rear axle ratio, carburetor barrels, number of speed, width, weight. You realize that, oh yeah, this is this car data set, which has a few attributes, right? Look at this guy, right? You see the torque somewhere there. Torque is 30 instead of 32. You know why it is 30 instead of 32? It is because NAN, right? Because for 2 items, there is no torque in there. So we will see, now we will see how to handle these things and what do we do about it. So the other basic operation is if you type df cars, it won't show the whole thing. It will show some part of it, right? Because this is only smaller data, otherwise Pandas is enough. Otherwise, if you have a record, for example, by the time we get to the rexes, it has like 33 million records. It's not going to display 33 million records here. By that time, what it will do is it will show the first 20 and the last 20 or something. Of course, I'm not going to do this on that one, but still, that's what it will do. It knows enough and it looks at it and says, okay, let me show some, but anyway, keep in mind, so it's okay. This is a good one, right? You look at and say, give me the head 3, give me the top 3, and let me take a look at it. There is another one, is describe. Describe gives you the count, mean, standard deviation, the quartiles, maximum, right? So now you can look at it, you get a feel for it. Oh yeah, there is this miles per gallon. These are, these are the kind of things that is in there, etc., etc. So describe gives you a quick snapshot, a nice snapshot that you can figure things out. By the way, if you give, this is an interesting one, right? So when you do this, right, when you square bracket and you put those things in, you are giving a column label. When you give a column label, wherever it takes a column label, you can also give a list. So keep that in mind, right? So that you get multiple columns, you get a subset of the columns, you don't get all the columns. So you can do that one. If you have the head, you have the tail, of course. Another important one, D types, right? Once you read some data, you also want to know what types they are, right? Whether they are integers, date, etc., etc. So D types are important. So these are the, so if you look at D types, tail, head, describe, that gives you a feel for how these things are. The indexing is the labeled indexing, right? If you index 0, you get this one. We will, once we start indexing, we'll come back to the indexing. But the key is you can index any row and say, give me that. This guy, right? See this one, right? This is like this. It is, it doesn't look as interesting as this one, right? When you do just the, give me the, remember cards.mpg.head that we are taking one column. You know what this object is, right? That's a series object because it's a column. So this is what I was talking about. When you look at things, some things might be series, some things might be data frames. You have to keep an eye on both of them. Yes, sir. Excellent question. Thank you. I was skipping it. No. Yeah, I will. So the question is, what is the difference between iloc and loc? Excellent question. Thank you. First of all, Pandas is not an array, right? Pandas is not an array, right? So that you cannot just say 0. What it has row. It is indexed by row. It has row labels. It has column labels. Labels can be anything, right? So in one of the things what Brandon was talking about, the label could be if you are taking the movie data set, right? The label could be the movie name. So you can actually index it by the movie name. That is all fine. Now somebody says, give me the 5th record. How would you do that one? So the iloc, if I am correct, it will give you the 5th record. But if you say loc, it so happens that in our data, right? In our data, that is why, see, in our data, the index is the index and the number of the row is the same. But it need not be. Tomorrow you could move it and you can say put the name of the car or something in there, and then when you do the 5th one, you will get that. So iloc gives you the 5th element, 5th row, but loc gives you the row with the label. It so happens that it is 5, but it could be anything. Does that make sense? So anyway, that was the question. The question was what is the difference between iloc and loc? Thank you. And this is exactly the reason I put that one in, so that, then I said, let me make sure that at least you get this thing out. This is the reason I was saying earlier. 2 things are important, probably 3 things are important, right? I'll take the third one later. But the first one is the objects, series versus data frame. We will see that when we start looking at more data, we'll look at why is this thing happening? That's one. And the second is this indexing, right? You want to make sure that you are able to index it. It is not, you can just go in and willy-nilly take something out. And you don't want to, right? Because if you have 33 million records in sitting there, you can't handle 1, 2, 3, and you can't put it in here. You have to deal with it in aggregate. You want to deal all the columns and the data in aggregate, and you need to do things with it. So we went to the labeled indexing. Good. So then see this one, right? This is what I was talking about, right? You can index it by label. You can index it by column name. Wherever it takes column name, you can give a list of columns, so that then what happens is you get more than one column. So you get a subset of the columns. So now let us go into one of the so we went through this one, right? Read in and out. You know that what you can read, what you can, This one, basic operations, head, tail. We saw these things. Labeled indexing, that's what we were talking about just now. NA. Remember, we were talking about the torque, for example, right? When we did the count, we saw only 30 torque. When you, as a data science person, right? As a data scientist, you know that all data, right? Data is not going to be clean. Right? You are dealing with a lot of data. Data might be missing. Data format might be wrong. Somebody might not have entered the data. It's not somebody entered the data when you do the, when you do the ETL. Some pieces might not be there. That kind of stuff, right? So now, suppose you want to model, buying habits of people. how do you handle it? Right? You have some pieces, or you have like 30 attributes or 50 attributes, and some pieces are missing in various other places. What do you do with it? Right? What is the most obvious way of doing missing data? Drop it. Right? Right? That's what it is. Drop it. It's good. You can drop it. But what is the problem? That means, so suppose you have 30 attributes, and 1 or 2 are missing here, 1 or 2 are missing here, 1 or 2 are missing here. When you start dropping, what happens? By the time you start dropping it, a lot of your data is gone. Right? Because you can. Fine. So then, what is the next best alternative? Impute. Right? Thank you. Right? And impute data. Right? Now, the question is, that's fine. So what you are going to do is, for the pieces of data that you have, you want to put things in, which is good, excellent. So then what do you put in there? Yes. Thank you. No, thank you. No, go ahead. Yeah. Excellent. Thank you. Because imputation itself is a bigger. You can do mean, right? You can do mean. Mean is fine, but then it might not be, right? If the mean almost assumes a normal distribution of the data, right? That's why you're putting in mean. But your data might not be normal distributed. Just for example, right? You might have, say, for example, you are looking at some readings for, say, health reasons, right? So if for sick patients, what might happen is the readings are high. Right? And if, for example, very rare diseases, 99% of the data will be, won't be high, and only a few of them will be high, right? So now if you put the mean, what happens? All of them, you're putting all of them as healthy people. That's not right. So what you have to look at actually is look at and say, I have this data, 99.95% of the time, this value is between 10 and 30. And probably, come on in, guys. Come on in, sit down. Let's go. So 99% of the time, 99.5% of the time, it is between 10 and 30, but 0.5% of the time, it is 120, right? So now, this particular field, you have about 500, say 100 data is missing. So if 100 data is missing, you're not going to put everything as 15. You have to look at it and say 95 of them are say, between 10 and 30. So you have to do some random this thing and say 10, 20, 22, 23, 50. And then 5% of it, you do have to put like 100, 110, 120, etc. So there are, it gets more and more interesting. Anyway, I'm not going to go deep into it. There is also another story. NAN, right? Yes, sir. Yeah. So we have the is null. So the excellent question. Let me go back, and I had it somewhere here. Anyway, the is null is the one to figure out. We will do that one here as well, right? So because remember, you have to look at it and say is null. I'll show it. We have this one is null in this column, and you can do many things. You can say is null. You can pull actually the rows out. You can do many things with that one. Mm-hmm. No, but remember, each column is, this is a heterogeneous thing, right? So you cannot, the average of age is not the same as average of fair or something else. So yes, you can do is null and it will give you the whole thing, but you have to treat it column by column. And if you want to do it, you have to go surgically and say this column is age, so I am going to take an average age. This column is something else, I'm going to look at it, and there might be categorical columns for that matter. So that is why, thank you. It's an interesting discussion. I hope, we will sit through the lunch and maybe the dinner as well. But, which is fine. Because the NA is an important one. This is one of the interesting ones, and Pandas helps a lot on that one. I mean, helps a lot means it has 6 or 7 functions. That's the best it can do. Does that make sense? Mm-hmm. Absolutely, absolutely. Yeah. So even though Pandas gives you only 6 primitives, Panda doesn't give you all those things. So for example, the Titanic data that we will see, a lot of age is missing. So either you can put the age as average age, or you can look at it and say Mrs., Miss, Junior, etc., and then say, what is the average age of Mrs., which is a name in there, right? So I look at Mrs. and Miss and Master and that kind of stuff, and look at the what is average age, and then based on that one, I can actually impute ages there. Yeah. So you have an in place equal to true. You have an in place equal to true. If you do in place equal to true, it will go and change that one. Otherwise, it will return a different one. Yeah. In fact, in place equal to true is there in many of the other transformations as well. By the way, just to give you this thing, I also, I'm writing a book on Spark, Apache Spark, and that kind of stuff, right? So there are that's an interesting. So if you use Apache Spark, for example, the APIs are very similar. So the data wrangling that I do here, I have also on the Apache Spark as well. So it's an interesting one. But there, it always gives you a new one. There is no in place in Spark. It always gives you a new RDD. One more point on NAN, and then I will go. NAN is always, you can't look at it and say it's bad. It's not. So, for example, the recommender that's happening on the other side of the room, right? When you do collaborative filtering, right? What happens is you suppose you know that you have rated 2 movies, somebody else have rated 5 movies, and if there are common ones based on that one, you can say whether you like this movie or not, which is all fine. But if you get somebody, right, who hasn't rated any movies, and then say, okay, give me a recommendation for this person, what would you do? You can't do anything, right? So you have to return an NAN, which says, I don't know. So NAN is good. And if that is there, maybe you can do, when you do count and various other things, it will give you NAN, and you can look at it and say, oh yeah, in this data, there are this many things that we have no clue about. So one way NAN is good, because if you put 0 in, there is no difference between 0 and if you have a 0 rating, you don't know. How do you say I don't know versus actual 0? So NAN is good, but you have to treat it, And Pandas has a skip NA and fill NA and interpolate. The interpolate is the one where you can do interpolate, all kind of stuff. There's interesting ones in there. Moving on. Drop NA is one. You can do drop NA. So if, for example, remember earlier when we did this one, it had, so now when you do this one, see 30, right? Because earlier we had 32 records. Drop NA, it recorded those 2 records, which had this torque to be NA. There is a skip NA, fill NA, and interpolate, right? These are, so interpolate is, you have got interesting functions where you can interpolate this one. So this is an interesting, okay. See this data, right? This is from Brandon's this thing. He gets this report which says sales. You have the royalty, this is USD, this is GBP, and this is euros, right? So he says, I want a column which says how much amount the customer spent, right? Which is units sold by list price, which is fine. But then the problem is the currency is different at different rows, right? Here you have USD, here you have GBP, here you have EUR. So how would you fill that in, right? So this might be a good thing to look at fill NA, and how do you do that? So what you do is, I'm just quickly going through because I think, first of all, you do the drop NA to get rid of all these spaces, right? First you do the drop NA, you get the drop NA, you get this like this, which is good. Then what do? You go in and amount spent, which is a new column, sales, star, units sold, stars, list price, right? Which is fine, which is straightforward. You add a column which multiplies the units sold versus list price, you are in good shape. That is good. Now how do you put the currency in? Any thoughts? Where do you have the currency? You have the currency sitting here, right? Yeah, so thank you. So the first is, what you have this thing here, right? So the first thing you can do is search for things in between brackets, right? So you get USD, EUR, and most of the things will be NA, right? And then what do? You put it in this column. So, X. Okay, I'm going to, you have to bear with me in the sense that because I have the whole thing in one column, I need to split it so that I can show you how this happens, right? So, I'm going to, what they say is you should never try these things when they're doing with the audience. I'm going to try anyway. So this is what? Remember this str? So this is where, you remember that we talk about this string functions on this str namespace, right? Str, sub str, and you have this regex thing, right? What you are looking for is, you are looking for things in between brackets. And when you find that things in between bracket, you are going to create a column and put it in there, right? Which is good. So this is, remember, the str functions act on a column, right? It is not on this thing. So when you do this, I have to, okay. So the first thing I have to do is to run all above, right? It has to run because I haven't been running these things, right? So let me run these things. So maybe I didn't have to run this one. So let me do this guy. Let me do this guy. Yep, sales is there. So let us go down. And these things are there. So first thing we did was drop NA, right? You drop all the frivolous columns, so now you have got at least everything is in pack, this thing. Now let us go down and just get the head one more time so that so you add a new column, which is very simple. After adding the column, what is our next thing? We search for the currency. We search for the currency. Actually, I should say we hunt for the currency. We do. We got it, right? See, tons of NAN, 1 USD, tons of NAN, 1 GBP, tons of NAN, 1 EUR, right? Because the brackets were only here, they were not here. Now what do we do? You have a fill NA, right? What do we want to do? We want to fill NA. You want to go up to USD and then fill the guys up with USD, right? Not down, right? So there is a thing in fill NA. Method is backfill. So you go in, fill NA backfill. See what happened? It went in, and we got nice currency thing on the top. Right? So I thought that it was an interesting, very interesting, parallel parking, because remember, I come from Volvo, so I do autonomous driving and that kind of stuff, right? So parallel parking and maneuvers and all kind of stuff, autonomous driving and all this, right? So anyway, see how we were able to use, here NAN was good, right? Because you had NAN, and you are able to say some of these had USD and various other things, you go in, you looked at it and said, give me backfill back, and you're able to fill it. This has statistics, so going back, switching back into this one, min, quantile correlation, it gives you the whole correlation, or if you covariance, all kind of stuff is there. If you want, so this guy, right, this one, this returns one number, right? What is the difference between this and this correlation? This correlation acts on a data frame, which returns another data frame with right? It is a cross correlation between all the variables. Here, we went in and we said, give me the correlation of horsepower versus weight. So this gives, so now we are doing a correlation on a series, and that gives a number, because you have one series and say, okay, give me a correlation between two series, it's nothing but a number, right? Because it looks at the correlation and gives you a number. So this is where you keep an eye on what type of objects you have, what type of operations you do. So then there is a plot, you can do the plotting, etc., etc. So I'm going to, oh yeah. So this is one. The group by probably is one of the most powerful ones, right? You want to look at, you have this car HP and weight and all kind of stuff and miles per gallon, and you want to look at it and say automatic and transmission. What is the, which one has better mileage, right? So what do? You group by automatic, and then you find a mean, right? So you say, take all the automatic. So this is the thing they call split, apply, and combine. You take the data, split it by automatic. So all automatic equal to 0 goes in one, or automatic equal to 1 goes in another this thing, right? And then what you do? You apply a function, which is basically mean. In other places, we will do sum, etc. We will see how that happens. And then you combine that together, so you get a tiny, you get an interesting data set, right? So this two frame is, if you do this, right? I'm going to try this. If it doesn't work, don't hold me to it. It's because we haven't done other things, but probably it will work, right? If you don't have this two frame, we got, what is this guy? It's a series, right? Because it's a column. So when it's a column, it gives you a series. Of course, we all want to work with data frame, so you do the frame, you get a nice data frame out of it. We will see more when we go into. Anyway, so this is a group by. Keep this in your mind, right? You can do group by various other things. So we are in good shape. So we saw the statistics. You have Pearson correlation, various other things, Spearman correlation, etc., etc. We saw the group by as well. So this is a good time. So now that we understand the basic maneuvers, now exactly 11:30. See, guys, I had that 11:30 marked there because I had always this thing on there which says this is where I should get to this thing, and we exactly go to that one. Thank you. You have been a good audience. Anyway, because we have only 90 minutes, so I need to cover the whole thing, right? Even then I have more than what I could cover. So anyway, now let us look at data sets, right? Now this is a time to look at data sets. Let us look at some data sets. We know what the basic things are. Before we go into data set, there is another one, merge, right? Merge is like the join. You merge two data frames. We will see how the merge works. Join is a, they also have join, which is a subset of merge. So always use merge. We saw the group by. We also talked about split, apply, combine. Another thing is stack and unstack. So what happens is we will. So these are the things where you will know more when you run it rather than looking at it from this perspective. Right? Anyway, just to keep in mind. Okay. So let me take from my ad tech experience, right? You have the TV data set, right? People who watch that kind of stuff, right? Then the one of the column is the type of the genre, for example, right? You have horror, child, adventure, etc., right? Now, and then you have all these things people watch and that kind of stuff. Now, you want to look at it and say, no, I need to take this thing and make it a column. So it's a transformation, right? You take a column and turn it into a column heading and based on the rows. We will see that one. I'll show it to you. But anyway, so what happens is it turns this thing around. It turns based on one column around. We will see that one. So the group by and merge and group by and unstack, these are the two powerful ones. We will see that one, right? Because this is our next, this thing, So how many of you have heard of the Kaggle competition? Right? Yeah, good, excellent. We have a whole Kaggle. So that means you have done most probably you have done the Titanic, that is one of the classic ones, right? And probably you have done the Titanic using Pandas, the Titanic dataset. So let us look it up. So let us employ our newfound powers, right? The ability to manage this one. Let us go in. So you have the trained data set. First is count. This should bring tears to our eyes. You know what happened, right? 714, right? Only 714 has age, and rest of them don't have, right? So that means we have to drop all of them. And remember, what we are predicting, we have the passenger ID, a class name, age, etc., etc. So what we are predicting is whether they survive or not, right? So age is an important factor, right? Maybe age is an important factor, right? But probably ages. So now we need to figure something out. So this is where one of the interesting things comes in. You have the head. We look at it. Yes, we have the, we see cabin, embark, ticket, this which says parent, children, sibling, spouse, right? So what it shows is whether this person has a sibling, because the idea is that maybe if you have somebody with you, you have a better chance of survival than if you have nobody, right? Nobody, who cares? Fine, right? Somebody, oh, no, we need to get this person out of this one. Maybe, maybe not. Anyway, describe gives you a description, and we do the describe, and here you can see that age gives you this NaN, because it can't do these things because there are NaN in the age, right? The age is missing. When it is missing, it says, no, I can't do this one. So the first one, right? Let us look at and say whether gender made any difference on the survival, right? So what you do, group by sex and survived, and then the operation that you do is size. Naturally, you get a series, right? You see this one, this has got double series, right? So this is a multi-indexed. There are two indices on it. The first index is the gender, and the second index is the survival, right? So this is the data, and this is the index, right? So now, but if you look at it here, right? How do you total them up, and how do you take percentages, right? You don't want to go in and take rows and start multiplying. Oh yeah, add row 1 and row 2, and then row 1 by row 1 plus row 2 and row 4 by row, etc., right? What do you want to do? You want to take this survived on the top, right? So you want to take that column and bring it to the top. What do we use? Unstack. Thank you. And we use unstack. Now we are in good shape, right? What happened is you get 0 and 1, and then you get the rest. So this is where, that's why I was saying, unstack by explaining won't work. But when you look at it, it naturally looks at it and says, oh yeah, so this is where when you do group by, usually when you do group by and when you have group by multiple columns, you get into a structure like this, right? Remember, these are the labels. They are not, they are part of the data, but the Pandas considers them as labels, right? So, and then now you want to turn them around and say, I want to get a nice, data frame out of it. You do the unstack, and when you unstack it, you get this one. Now, when you get unstacked, then you can also rename the columns, like dead and alive. You rename the columns, and then you add another column which says total, right? You do want the total number of males and the total number of females. You get the total, and you get the percentage. Does that make sense, guys? See how we were able to apply the group by, we were able to apply the unstack, we were able to add columns, and then we were able to do the column operation, and now you can see that 74% of the females survived and only 18% of the males survived. So anyway, so just to want to show that, so see how the manipulations come and how these things work out. We could have done, there is another thing called cross tab. the cross tabulation. So the cross tab also will give you the same thing. So interestingly, without all these things, we could have used cross tab and we could have gotten the similar structure. Then the rest of the stuff is, I have to show one this thing. So fine. So let us get a simple model, right? Very simple model. Let us say that all males survive, right? Just to see what happens. So we make a simple model. Again, Pandas helps us, right? You have a lambda which says, you understand this maneuver, right? This is just a double indexing, right? You have 0 and 1. And if it is male, you get 1, so you get the first one out of it. And then you apply that one. So you apply, so this is the test data, right? You have the test data. So you apply this model and you get a survived equal to all males survived. So don't go into the semantics because we are not doing machine learning. We are just looking at how we can do the thing. I wanted to point out one interesting thing on that one. So this is good. So let us do this guy, right? Let us do the group by survived and size and unstack, right? So what happens? You get this NAN. You know why, right? Because I'll show you why, right? If you do this, yikes. This is a good one. Probably, I hope that it is the error that I'm looking for. Key error survived, because I don't think I did this one, that's why. Because what I have to do is I have to go here and say, because I haven't ran the thing. So what you do is run all above. This is an easier one. If you are running that 33 million one, that would take some time. So I would not run it, but this one we can run, right? So then what we wanted to do was, we wanted to do this one and size, right? So because our model is that all males survive, right? So so you see this one, there is no female 1 or male 0, right? So when you do unstack, what happens? You get NAN. The reason I want to point out is when you do unstack, be careful. You will suddenly get these NANs, which were not there before, right? Because what happens is when you are unstacking, you are taking all these things and putting it there. So when you do that one, there might be rows that are not there, right? You would not have seen it, or you wouldn't have noticed it when you just used the earlier one. But when you do this one, so be careful. That's all. When you do unstack, NANs can appear. So once you do the unstack or things like that, you should check for NAN and you need to, account for it. So that's all what I'm going to do on this data. There is more in here. I actually have done some machine learning and a tree and regression trees and random forest model and that kind of stuff. These are more on the machine learning side. I'm not going to go through that one, but we have them here. You can take a look at it, and if you have any questions, ping me. I'll go through that. So this is good. So now we have gone through one data set. Oh yeah. So let us go through another data set. That is more interesting. The orders data set, right? So this particular data set actually has a lot of history to it. Nothing serious. I don't know. There is this Microsoft Access database. Remember they had some other database earlier as well, right? So in the very beginning, right, that was the only database available. And the Northwind, this is like people who sell things. This data set was supposed to be the data set to teach you Access, SQL, and that kind of stuff. This was years ago, probably 1990s or something like that, when dinosaurs ruled the earth and that kind of stuff, right? Now, so then I saw this data set somewhere, and I thought, oh yeah, this is an interesting data set. Now, instead of doing SQL and that kind of stuff, I use it for Spark and Pandas and that kind of interesting. So that's where this comes from. The data set has orders. So let us read the order data. Basically, order ID, customer ID, order ID, customer ID, you have the employee ID, order date, and the ship country, right? Simple. So you have these orders. You have the order details. Order details have, so each order ID might have multiple lines, right? Basically, these are the lines in an invoice, right? You have the each order ID, then it says product ID, unit price, quantity, discount, that kind of stuff, right? These are the lines in looking at an invoice. And they also have products and various other things. We are not going to use the products here. They also have employees, so you can use all kind of strange things in there. So which is fine, good. So let us look at the data, orders.count. This is good, right? There is no missing data, there is no impute, none of these. Details are good, so there is enough details, right? 2000 data, product is there. So now, these questions we need to answer. How many orders were placed by each customer? How many orders were placed in each country? How many orders by month, year? And then the total sales, right? That's what you will look at and say, give me the total sales per customer. And probably give me the average order, right? That's what you will look at and say, okay, give me the total sales per customer, give me the average order. So which is fine. But do we have all these? So first question, how many orders were placed by customer? What do we have here? We have the customer ID. So it's very simple. It is a simple group by operation, right? A simple group by operation. You do the group by customer ID, size, and sort value. So this is how you sort things in Pandas, right? So you sort the values because what you want is you just want to sort the values, so you want to get the customers who have the maximum number of orders, right? So you sort values. Of course, you get to a frame and a head. So it's a simple one, right? Does that make sense? So it's a group by, we have seen it before, you just group by customer, you're done, right? And then you do some sort values, that kind of stuff. How many orders were placed in each country? Now we know how to do this one, right? It's a group by ship country, right? If you group by, because we have our data here, which says you have a customer ID, you have a ship country, you are only looking at the number. So that is why you use a count or size, right? You look at and say, okay, how many orders are there for each country? You're done. It's an easier one. But once we get into the questions 3, 4, and 5, right? How many orders per month, per year? Or give me the total sales, or give me the average order per customer. Now we got a problem, right? Because this doesn't have, two things it doesn't have. It doesn't have any date thing at all, right? It doesn't have any date thing to get month, year thing. And it doesn't have anything to say what are the total sales per customer, how many things did they buy, how much dollars they buy, right? Those things are here in the order details. So now this thing is, do Pandas thing on the order details, get the various information out of this guy, put it back into our orders, this thing, then we know how to do it, right? Then we know how to do the group by. So let us see how we start doing that one. It's not that bad. Step number 1. We have in our order details is a strange table, right? It has this product, sorry, that's this guy. I see chai here. I feel, actually I feel thirsty to drink some chai. Maybe we should do it after this is done. See this guy? Order ID, right? You have multiple lines in each order, and you have the price, quantity, and discount. First thing we do, what do? We get the quantity price, so you get this total, this thing, right? Unit price, quantity star price minus discount thing, right? So you get the unit price here, and then you need to aggregate it for all the orders. So that's not that bad. You go in here. First you add the order detail equal to unit price star. Remember, all these multiplications and things like that work on a column, right? They are not working on a single piece of this thing, right? So you do this one, and then what do? you aggregate by order ID, right? When you aggregate by order ID, you get this total for each order, right? So now group by order ID, and the thing that you use is sum, right? Because now you want the sum of all the orders. Do the sum. So now you have the order ID and the order total. So what do we do next? Yeah, no, I mean, what we do is we do a join to the top one, right? So this is where the merge comes in, right? Oh yeah. This one has a slight problem. This order ID thing, right? What is that order ID thing? That's a label. That's not a column, right? Because Pandas, remember this thing has this is the raw label. Remember this, we were asking about iloc, for example, right? If you do iloc 1, you will get 440. I mean iloc 0, you will get 440, right? But if you do loc 0, you will get nothing. You have to say loc 10248, because loc is a label, right? Iloc is a position. So this is where the iloc and the loc comes in the picture. But going back, all those guys, right, 10248, 249, these are all labels for this guy. If you want to join, how do you join? Right? So what do? There is a thing called reset index. When you reset index, this is like that, remember we were talking about this, what was that thing? Unstack. Similar to the unstack, suddenly this labeled multi-index is a single index, but multi-index, this thing becomes see that now, they just gave you this number, right? 1, 2, 3, 4, 5, this is just a number, and then order ID became a normal column. So now you can go back and say merge. What you are going to do is take this thing, merge into the top one, and voila, you have your order total for each customers, right? Now we are in good shape, right? Now we can group by customer, we can group by country, and then we can get the total, how much this thing people came, and how do you get the average per customer? Instead of sum, you use average. Remember, the group by is nothing but a, what is that? Apply and, right? It's a map reduce thing, right? Split, apply and, combine, right? So if you just get a group object, it will split and give it to you. You can apply anything you want. I mean, it's not anything you want. You can apply things like size, group, size, average, mean, total, sum, etc. Right? So when you want the average, we take that thing and apply the average. If you want the total, we take that thing and apply the sum on it. And that's exactly what we do. We do the merge. Did the merge make sense, guys? No? Merge on order ID. See, what happened is, we had.
Does it choose that by default?
Which one?
So, how
Yeah.
do you know what field to join?
Excellent, excellent. It is by default. It's by default. Hold the thought when we do another one. So it can be default, or you can also give and say left on and right on, and you can give the column name as well. So Pandas is, thank you very much. The question was, is it by default, right? That is a good question. The reason that is a good question is because you have two data set, and if you have the column names the same, Pandas will figure it out. You don't have to give it things, right? So these are some of the things that it does, right? It does that extra step of going them. Yes, if you have some two names which are same name but different data, then we are in trouble. But most probably that shouldn't happen, right? One of the basic tenets of data science is that you should always name them correctly, right? Whether it is on this table, whether it is on that table, whether it is some other table, you have to name it correctly, right? I mean, name it appropriately, because if you have the same name saying two different things, we are in deep trouble. So going back, we have the order ID, product ID. This is our details. From the details, we sum up the total for each order ID. So we get a table which says order ID and the total dollars for that order. We take this table and we go back to our orders table, has order ID as well, and then we tack in that order total here. Right? This is the details. This is the order header. right? Order header has the order ID, and so we get the total here. So suddenly we get this nice table which has all these things. And so you see how we were able to get in, we were able to gather all these things from multiple tables, take these things up, and then put it in there, right? Now we need, in our question, I'm going to go a little faster, but our question is aggregate by, by month and year and that kind of stuff, right? So by month and year, what do? You have the order date, right? Turn the order date into a date time. We do the date time, turn it into a date time. And then, remember this DT, remember I was talking about this is this namespace which has all this date time. We get the month and year out of there, right? So suddenly you have two more columns, which gives you month and year. Now we are in good shape, right? We can answer all questions. Give me all customers, total of all customers by month and year. What do? Group by year, month, and then sum, right? Because you want the total, right? That's exactly what we do. First is how many orders. So if you want how many orders, you do the size, right? You say, okay, how many number of orders for each customer grouped by year and month. See that one, this is where the multi-index comes in, right? You have the year and month, and then I did the reset index and head so that you get this nice data frame model. Now the total, if you want the order total, you do the sum. Remember, the thing is, you have the split. You split by group, so you have these records packed by the group, and then you can apply the functions that you want. You can apply size, then you will get the number of orders. If you apply the total, you get the total of the distance. And that's about it, right? Then you do the rest of the stuff. Average by customer, instead of total and this thing, you do the average. You do the group by customer ID and give me the average, and you're done. And so now that you understand the group by and this thing, you can do all kind of manipulations with it, right? You take this one and also see, remember the merge, the group by, this unstack, reset index. If you have all these things, you are in good shape. Does that make sense? We still have enough time. Let me see how I am doing on my time. Yes. Excellent. So 20 minutes actually. So now let us do some serious business, right? So this is the recommendation systems. This is a Rexis conference. Usually that happens every year. And during the conference, there is also a challenge, so that people, do the challenge, and then there is actually Rexis challenge itself is a track by itself. Then about 10 or 5 or 10 papers of the people who have done the top this thing, they discuss how they did that one, etc., etc. So let us take that data. So let us get this guy out. So there was another data that I was going to use. This was the text analytics. So the text analytics was interesting because I'm still, but I know that I didn't have to get time, so I was not going to attempt it. The idea was to get the State of the Union, right? The State of the Union by the presidents. They reflect the times, right? George Washington was not talking about WMD, right? Or he was not talking about Iraq. Right? So if you look at the State of the Union, analyze this thing, get the number of words, the top words, you will know, okay, they were talking about union and they were talking about freedom and things like that, right? Now we don't care about any of those things, right? So anyway, so that is that side of the story. So I have the State of the Union, we were able to, and then we were able to compare and say, what did Bill Clinton say that Abraham Lincoln didn't say? Or what did Abraham Lincoln said, right? By looking at the words, you can look at and say, oh yeah, or Barack Obama, what were his major these things, what were the differences? We could do all kind of interesting things. I have that thing in there, but I don't think we'll get time, so I skipped that one. By the way, I also have, but make sure that this data, only you look at it, this is like an R data. This is the Republican and the Democrat, I'm just kidding. It's the debate data, right? So I have that data as well. Now you can look at the debate data, right? And then say, what were the things that Trump and his gang were talking about, and what were the things Mrs. Clinton and Bernie Sanders were talking about, right? It's an interesting thing, right? So I have all those things, and I was going to go through and use Pandas to take it apart. There are a lot of interesting things, like split, and you have to take common words out, and you have to take commas out, and you have to take quotes out, and you have to, all kind of stuff is there. But I didn't get time, so I'm going to leave it up to you to. But I have those things in there. So it's an interesting exercise in a very different way, right? We don't deal with numbers. You're dealing with words. You're dealing with, quotes, words with comma, words with hyphens. So now that is a very different way of looking at it. You have to do things with that one. Anyway, I'm going to pass that one and go into this Rexus guy. I don't have this data in there because the data is like about 2 gigabytes. So I can't put it in GitHub. So what I have done is, if you look at each data subdirectory, I have a README text in each of the data subdirectory where I put the lineage of the data, where I got the data from, or where you can get the data from, the source and that kind of stuff. So if you want to do this one, you can go to the Rexus 2015 challenge. I have also put the URL in. Go to the URL, download the data, put it in Rexus 2015 subdirectory, unzip it, and then you can run this program. This thing, I'm not going to run it, because I'll show you why. So this is, I can run this guy. I can run this one. I can run this one. So there are 2 files. So what these files are, this file will take about 2 minutes to read in, right? What are these files? So these files are, so this is e-commerce, right? So these are, in some sense, these are clicks and buys, right? That looks like a, I don't know, it looks like a song group, or maybe it's a good this thing for an e-commerce thing, right? Clicks and buys. Anyway, so it has session ID, timestamp, item, and category. So these are the things that people click, right? You go into this thing, you click on a particular item, it has a timestamp, it also has a session, right? So you go in for a particular time, click, you do a few other things. And it also has the buys, right? It has the same session ID, the timestamp, and the item bar, right? Naturally, the clicks will be huge, right? It is, if you look at the clicks, there are 33 million clicks or something like that, right? About 1 million buys records, right? It's 1 million, and the clicks are about 33 million clicks, right? So that is why this data is like about 1.5, actually 1.2 gigabyte total, approximately 1.95 gigabytes or something like that, right? So you have like 33 million clicks, and out of them 1 million buys, you have the session IDs and that kind of stuff. So our mission, if we choose to do so, is to predict, right? They will give you a set of clicks and say, predict what people will buy, right? So now the question is, how would you know? What would you do? Look at it, right? So, thank you. So you look at it. So you have the head. So you look at the count and the head, right? So then you have all kind of things that you can do, right? You look at it and say, maybe some items people buy more frequently. Maybe some items people buy on Friday. Maybe some items people buy without looking, right? Because these are utility items, right? You're not going to look at multiple things. You look at it and say, you look at it, I want this, click it, buy it. There are other things you spend a lot of time. Maybe you do the repeat this thing, etc., etc. So there are all kind of things that we can do. And we have these 33 million records here, and we have this 1 million record here. So now let us use Pandas to look through this data. And I think we have 15 minutes to look at it. And of course, after that, this thing will self-destruct, right? So the first thing, there are 3 pieces. First thing, when you get a data, you look at the data and make sure, right? anomalies and incongruencies and that kind of stuff, right? Things out of whack. This thing is not there, that thing is not there, because you do want to make sure that the data is clean in some sense. Once you have that one, the second thing is you look at the data and say, how many items? What did people buy? How many sessions? Did every session become a buy? Did everything that bought had a session, had a click, etc., etc.? And the third thing is you extract features. You look at it and say, I think I need day of the week, right? People do things on Monday. Monday, probably not many people are going to buy things. Maybe Friday, people will buy more things, right? So if you want to predict whether some click will turn into a buy, you look at it and say, yeah, this is a weekend, I think there is more possibilities, right? Or you look at the day of the week. You look at the date, you look at the month. Maybe some items people buy during Christmas, some items people buy during this one. So if you know all those things, you will be able to do things, right? These are some of the transformations. So this is where you extract the features. So we will cover in a part of these things, a little of all these things. First is verify the date range, right? You have the buy, you have the clicks and the buys. You want to make sure that the date ranges are, right? If you have some clicks without any buys or some buys without any clicks, you can't make anything out of them, right? So what you might have to do is you might have to just delete those records. Luckily, we don't. So this is this thing, right? So when we read this one, when the read CSV, right? In the read CSV, we did one trick. We did parse dates as timestamp. So we didn't have to do anything. The read CSV itself parsed it, and it gave you this guy as a timestamp. In fact, this is where we have the. So if you look at the D types, you will see that it is a timestamp. So that's a good thing, because we already have because this time is important, right? That is already a timestamp. So we are in good shape there. So what we do is we look at the timestamps and say, give me the min and max, right? Give me the min and max of the clicks and the test and the buys, and make sure that they are within this thing, and they are, right? The clicks are between probably 3 a.m. and 2 a.m. on 2 days, April 1st to 9:30, and these are all within the. So we are in good shape, right? We don't have to do anything on the date side. So let us do some stats, right? The D types. This is where we know session is an integer, the timestamp is a timestamp. We know that it's a timestamp. We are in good shape. So now we do the count, right? Now we know how many records are there. That's the next thing to do, and look at and say how many records are in these things. We know the count, we know how many records are there, that is good. So first question, you look at it and say, what is the first thing they have given? They have given us the session ID, right? So let us look at and say how many sessions? What is up with these sessions? Are all these good sessions, all these bad sessions? First is unique sessions, right? So what do you do? Click.session, and you do the unique and size. So you know number of unique sessions. You know the number of unique sessions that resulted in clicks, unique sessions that resulted in buys, right? And then you do a percentage. So you have an idea. 5% of the sessions have become buys, right? Unique sessions. So that is good, because that means people click a lot of stuff, they don't do a thing, right? 5% of the stuff, 5% of the time, the clicks turn into a buys. So that's a good thing, right? So you see that how we can do unique, we can do size, and that is how we get that particular thing out. Next one, same with the buys, right? Unique items. Now you look at it and say, did all items end up people buying all items? They didn't, right? If you see people clicked on, say again, click, item, unique, right? Because we have this, when we go back here, the things that we have are session, timestamp, item. Right? I'm not doing anything with the category, but that's a whole set of things that we have to do on the category as well. We can do similar things on the category. So we go in and say, okay, item, give me the items. That's interesting. So people clicked on like 52,000 items, but they bought only 19,000 items. So keep in mind, right? So this is what I was talking about. So now we are not going to say whatever 52 minus 20, 32, right? About 32,000 items. We are not going to say people are not going to buy them, right? Remember, this is a slice of the data. This is a sample of the data, right? But people would buy other things, maybe other times. So we cannot just predict and say, nope, they're not going to buy those 30. So that is where it gets more interesting, right? But be careful that you won't look at it and say, oh yeah, because people didn't buy on the test data, people didn't buy on the data that we have, we are going to follow that one. You can't do that. So this is where I was talking about saying that, this is there are things we know and there are things we don't know. And we need to know each, right? So the describe. So describe gives you count, the standard deviation, etc., right? You can look at it and say, yeah, mean. If you look at the item, so the maximum, some people have bought like 144 items in their shopping cart, whatever it is. Minimum, of course, is one or two or three is a major one, right? If you look at it. Now, you can go back and say, give me a plot. So you have a plot, and you can look at it and say, oh yeah, between the mean is probably 2 or something like that, 1 or 2, and then about 40, 50, and then there are these outliers sitting in, right? So you are able to get that one. Another interesting thing, right? You want to get the duration, right? One of the important thing is, if people spend more time on clicks, do they buy or they don't? Right? You can look at it both ways. Maybe people are bored and they are just clicking. So if they spend more time, maybe they won't buy anything, right? If people want to buy something, they will go in, click on it, buy, and walk out. So you can look at it and see if the session are shorter, most probably you'll end up buying, right? Because shorter sessions, what else do you do? Anyway, so now let me ask you a question. How would you get the duration of a session? Right? This is what we have. Right? How would we get the duration of a session? So this is a very interesting thing, right? So what do we do? Yes, min and the max of what? Yes, but how would you do a min and a max? Because it's not min and there's only one number, right? You have to go through each session, right? And you have to get the min and the max, and then you have to find the difference. Yeah, you are saying something. Yes, exactly. So what we do, thank you. So group by, right? What we do is first, remember, it's not easy. If you look at it, even if we want to do it, it's not that straightforward, right? Even if we have to do it, what you have to do is you have to go through each session and then go through the timestamp. Give me the minimum timestamp. Give me the maximum timestamp. You need to come. So it's a lot of work in there, right? It's not little gyrations here and there to get that one. Pandas does it very well. Pandas does it very cleanly. So what you do? First thing you do, it is not, even in Pandas, it is easy, but it's not, you just have to, first thing you do is you group by session, right? So you group by session, you have these sessions in there, right? And then, so remember, when you do group by session, what it does is it turns this session into an index, right? If the session is a column, we can't do much with it. But if it is an index, we can do things with it. So you turn that into an index, and you just do a min. Let me ask you this. If you do a min on a column, what would it give you? The minimum of the column, it will give you one number. It will say this whole column minimum is 2. But because this is a multi-indexed, remember, this is where the labeled multi-indexed column, what does it give you when you call about minimum? It gives you minimum for each unique index. So it returns a column, session ID, and the minimum for that session ID. So that's an interesting one, right? That's exactly what you're talking about. So now what you do, indexed column, right? First you index it by session. You say, give me max, give me min. So you actually get two things with the session ID in there. And then you find the difference, you get the duration, right? Because the max minus min is the duration. So that's an interesting trick to it, right? So you do that, you do a group by, you get this group by thing, and then you do the min and the max, and then when your duration is min minus max, again, these are all column operations. So in the end, you get this nice column with the session and the timestamp which says the duration of that session. So that's a good, right? It's a very good, nice operation that gives you that very powerful operation. So now you look at the duration.describe, etc., right? Now you can look at it and say maximum durations, minimum durations. You can actually put this duration into something else. Yep, 2 more minutes. So now how many more minutes do I get after this is over? Can I get 10 more minutes, or how does it look? So anyway, I will quickly, there are actually, there are more things in there. The other thing that you do is you want to compare click and, so I'm going to take 5 more minutes, guys. Is that okay? Maximum 10 more minutes or so. Is that okay? I don't want to stand between you guys and lunch, but on the other hand, I'm actually more hungrier than you all probably. Anyway, so I might run out. Anyway, so now another thing you want to look at. You want to look at it and say, I want to compare these buys, and I want to compare the clicks and buys, and look at it and say, how do they line up for each item, right? How do you do that one? First of all, you group by session, item, and the quantity. So you get this for each session, for each item, what did they buy, right? And the same way on the click, you do the same this thing, right? You do the session time and the timestamp. So you know that for each session, for each item, how many clicks they made, right? Now what you can do, so you have the group by, and you do a merge. So this is where, earlier you were asking about the indices, right? So remember, these two columns, these two data frames, these are indices. So when you do a merge, you can say merge on these two, how is outer, and left index is true and right index is true. So what you are saying is don't merge on same named columns, but merge on the index. Our index is basically the session and item ID. So it merges that one peacefully. It looks at it and says, oh yeah, this thing has this thing has this thing. And you know the outer join, right? When you do the outer join, you have the clicks and you have the buys, right? So it will include all the clicks, it will include all the buys, and if you didn't find the corresponding clicks, it will put NAN in there. So this is where we actually want NAN. So then we can look at it and say, are there clicks without buys? Are there buys without clicks? That kind of stuff. Anyway, so you do that one. And then you can do count, and so you can look at it. So this is where you're asking a question, right? The is null thing. So I want to find out if there are any buys without clicks. There are none, because we can look at it and say there is none. So anyway, so this is where you can use is null to find out. There are more maneuvers like this. By now you know, right? You have the group by, you have these things, and you manipulate with these things, and you get more and more interesting things. The feature extraction, one of the feature extraction is the, so this is what I was talking about, right? The hour of the day and day of the week, right? So you can do the extraction. Now you know that, right? You create a column, you use the DT to get the day of the week, hour of the day, right? Because you already have a timestamp. So you can actually get these things in. And once you get those things in, then you do a group by. When you do a group by and you change the and you change your group by, and then you do our join, right? When you do a group by and join, you will get the number of clicks per day, number of buys per day, right? You get this guy, and then you change this one, and you get this nice table. It says on Sunday, these many clicks and these many buys, right? Now you look at it and say, you can actually plot a graph if you want to plot a graph, right? You get the nice graph plotted because you just plot it and say, hey, see how we had this huge data, right? This is like 33 million data, right? We turned this around, we added columns, we did group by, et cetera, and we got this nice, this thing. We looks at it and says, now the key comes in here, you calculate the percent. If you look at the percentage, you realize that Monday, the percentage of buys are very low, and Friday is where the buys happen. So key, if you want to save money, browse on Mondays, right? Anyway, so, but see that we are able to take this thing and we are able to munch this thing and we get this. By the way, you can do the same thing with the day of the month, right? Maybe on 31st or 30th, or when people buy more things, maybe on the 1st or 2nd people don't do it, et cetera, right? So you can see that how these manipulations, we can do various things. There are all kind of other techniques and graphs and that kind of stuff. And I think that's where, yep. I have some reading list and various other things in it. And thank you. This is where I end. Just have 4 minutes extra. Thanks, guys. Questions? You can now. Now it is your time. You can ask it.